Hello students, today we will be talking about real-life application of exponential equations. Okay, so here we're going to have some comparisons. Now it's called 7.5 here, but in reality it should be 14.3 because it's a continuation of Unit 14. Our objective is I can solve a system of equations involving exponential equations. So here is the system that's shown below. Y equals negative 1/3 x plus 1, which is a linear function. And that linear function is shown right here. Excuse me. And then we have y equals 1/3 raised to the power of x. That's an exponential function here. So it says give the intervals when the linear function is greater than the exponential function. So when this is greater than this one. So that's going to be right in here in this little interval right here. So it's when x is 0 here and when x is 3. Now when x is 0, they're even. So we do not count that point. And when x is 3, that's where these two lines intersect, and we don't count that point because it's asking when it's greater than. So remember, when we do not include the point, we put parentheses. So it's between 0 and 3, and that would be their x values. Now it says give the intervals when the exponential function is greater than the linear function. So the exponential function is greater all in this area. So since it begins at, I was going to say eternity, but that's really infinity. Oh man, I'm trying to remember where infinity was on here and I cannot remember. So anyway, so I'll just put it right here, but it's not till positive infinity. It goes from negative infinity to 0. So it's when x goes from negative infinity to 0, that's when it's greater than the linear function. Is it any other time? Okay. What about here? See how the linear function goes down to the negative values? And right here, there's going to be a horizontal asymptote, so this will keep approaching 0 but never ever cross it. So we have a second interval that goes between 3 and infinity. And there you have that answer. And again, you should have the sideways 8 for the infinity values there. Okay? Then it says complete the table and graph the system. Use the graph to answer. Okay? So if I'm going to complete this table, I put in 0 for x here. A half times 0, 0, plus 3 will give you 3. So for this graph, I can go ahead and plot that point. Let's see if I can move this. Maybe the little finger will. Maybe not. Okay, so then I put 1 in there. A half times 1 is a half plus 3. So I can put there is 3.5. Okay, then I put 2 in there. 2 times a half is 1. 1 plus 3 is 4. Okay, then we put 3 in there. Half of 3 is 3 halves plus 3. 3 plus 3 halves should be 4 halves, or 4.5. Not 4 halves. 4 halves is 2. Then we put 4 in there. 4 times a half is 2. 2 plus 3 is 5. Can you see the pattern here? If you see the pattern, then you know that this is 5.5. Okay? So if I plot those points, ooh, that's going to be a big dot. I wonder if I can make it a smaller dot here. So I'm going to go 0, 3, 1, 3.5. I'm going to have to go away off of that. So 1, 3.5. Oh, maybe it won't let me plot the specific points. 2, 4 goes here. And then if I put 4, that still might not work. 4, 5, Then I wonder if we can draw a line. No, it's just going to go a horizontal line. That's not what I want. Okay, so connect these points and make a straight line over here. Yeah, I don't know if it's going to let me do that. So draw your line there, straight line there. So now y equals 2 to the 0, or 2 to the x power. So if we put 2 to the 0 power, what is that? Everybody should get this. Anything to the 0 power is what? Okay. Then 2 to the first power. Okay. Then we go 2 to the second power. Okay. 2 to the third power. Not 6. Some of you are thinking 6. Okay. 2 to the fifth power. Or 2 to the fourth power, 16. And then 2 to the fifth power. So 1, 2, 4, 8, 16, 32. Okay. So if we graph that, okay, 3, 1, 3, 1 right there. Wonder if I could make it a different color. Let's go with red. Okay. And I'm going to go with the dot. Okay. So 3, 1 is right here. It would be 0, 1. So let's trash that. 0, 1 is right there. 1, 2. Actually, I'm going to skip it. 2, 4. So it's in the exact same spot over here. 2, 4. And it won't let me put one right on top. So then I go 3, 8. And again, it wouldn't let me put a red dot right there. Okay. It didn't show any negatives here, but it actually will go down over here. So I could put these red dots along this line. So it would go like this. Let's see. Ugh, I can't get to the one I want. The one that's below the line, I want to be above. So know that this is getting closer and closer to 0, and then it goes up, and then it starts skyrocketing up there. Whereas this line goes straight across this problem here. Okay. I'm going to go ahead and do the rest on a whiteboard. That'll be much easier. Okay. Talk to you later. You rock, students.